the top theorem to your neighbor. Go, talk to your neighbor, everybody. Say, hey. Everyone's reading. So we're going to find the area of the bounded region by hand, okay? And it'll be the exact value. So area of the region. And last week we talked about definite versus indefinite. For our case, I'm going to elaborate this guy right here. Definite means there is a bound given to us, some number to some number. And then we have f of x. Now, is f of x pertaining to our domain or the range? Domain. F of x means y. Y is our range. So that is the value of our height. And then it says dx at the end. Dx basically means change in x. And that change in x is basically x2 minus x1. And that is basically our width. So here's what's actually happening to the calculation when we're finding the integral or the area under the region. So I'm going to start off by highlighting this area right here, or the bounded region. And what's going to happen is it's going to take from the given to the very end. It's going to calculate as many rectangles as possible and sum it up all together to give us the approximated length. So for that, I want you guys to make something. How wide you make does not matter. I just want you to draw a rectangle. So change in the width, that is our dx. And how high that is, it is our f of x. That's kind of hard to see, right? F of x. Let me kind of point to it, that's f of x. So again, what the integral is doing is taking length times the width, many of them, and then putting them together and adding them up to give you the exact value. So let's look at an actual example so you're having a better idea as to what I'm talking about. On the bottom here, given the integral, if I find the antiderivative, meaning the integration, and plug in the b value minus the a value, that's going to give us the exact value of the area under the curve. So let's apply this. Looking at this, it says to find, do we have a number? Oh, here it is. So we're integrating. Looking at your graph, what number are we starting and ending? Negative 2 to 2. The function given to the right is 4 minus x squared. Again, just like last time, if you forget the parentheses around 4 minus x squared, it happens. I might make that silly mistake as well, so it's perfectly fine. So it says to find the integral. So if I'm looking at this, what is the integration of 4? 4x. And if I integrate negative x squared, it's going to be 1 over the new power of the x cubed. If you're like, what is going on? Maybe you haven't been practicing your homework. What do I have to add at the very end? Plus a c. Now my bound is going to go from smaller on the bottom to the bigger on the top. So let's see what that basically says according to our formula. It says after you integrate, plug in the first value, plug in your second value, meaning the upper bound minus the lower bound. Let's do that. We are going to plug this number into my x. And yes, we're not plugging anything on for the c, but we're leaving it as it is. So 4 times 2 minus 1/3 times 2 all cubed plus the c. That was just for f of b. Minus. Now, when you are subtracting, at some point we have to distribute everybody inside. So I'm going to go ahead and bracket this to begin with. Now we're plugging in the negative 2 in place of the x. So we have 4 times the negative 2 minus 1/3 times negative 2 all cubed plus the c. The nice thing about this format is, if it's a free response question, you may leave it right here, plug things in, and not distribute or simplify. But then I'm going to look at it for the multiple choice sake. What is happening to my c once I distribute in the end? positive c. When I distribute my negative, what happens to my c's? So do I ever need my c from here on and out? No. So if I give you a definite integral, you don't need the c anymore. But if you're having a hard time, put them in and you'll realize they eliminate. So let's do our simple math. 4 times 2 is how many? 8. The next one is going to give me 2 cubed is 8 over 3. Since I don't want any decimals. And I don't think over 3 is pretty anyways. And then our next one. When I distribute this right here, that's going to give me positive 8. When I distribute to the next one, what is that going to give us? That alone is going to be a negative, another negative, to another negative, so negative 8 over 3. If you need to write out the small steps, go for it. And then that's going to give us the following. How many would that give us? Ooh, 16 over 3. Uh-huh. 32 over 3. And if you wanted to make it a mixed fraction, it's 10 and 2/3. Now, they're both good. And if I want it as a multiple choice as a final answer, that is what I want. All right, so then let's move on to the back. I'm going to go on to example number 4. On example number 4, before we actually integrate, let's first figure out what area that it's bounding. So it says find the area bounded by this graph. All right, go ahead and highlight that piece. And also bounded by the x-axis, or the x-axis and the vertical line. So my x-axis will be right here. And my vertical line at x equals 2 is going to be right here. And then it says x equals 1 as well. So I can go right here. So if I were to bound all 4 of my components, my highlighted image will be the following. Let's all color. And let's kind of approximate how many total units this might create. Let's do a lucky guess. I know for sure that's 1 right here. 1 whole square, right? And then could I say this is about almost 2 if I take part of the top maybe? All right. Do you think this is more than 3 square units or less than 3? More than? So are we guessing maybe 3 point something? Anyone guess less than? You're pretty sure it's 3 point something? Okay. So that's our approximated value. And let's see if the integration will give us some number around it. So here we go. So we know the lowest point is 0. Highest point is 2 on our domain. So let's write our definite integral. 0 to 2. The function given says 2x squared minus 3x plus 2. Oh, I forgot dx. Maybe parentheses would be nice. If you forget, that's okay. Let's go ahead and integrate. If I integrate the first one, it is 2/3 x cubed. My second one is negative 3 over 2. Go. 3 over 2x squared. And then we have plus 2x. And our bounds are 2 to 0, or 0 to 2. Okay, let's go ahead and, I forgot plus c, but do I need it if I'm looking at definite integral? Because in the end, plus c and minus c is going to cancel each other out. That's a first thought. If you want to write plus c, that's okay. All right, let's plug in the 2 now. When I plug in the 2, I get 2/3 times 2 cubed minus 3 over 2 times 2 squared plus 2 times 2. Now, the nice thing about the next one, when I plug in the 0 into my domain, what is that going to give me no matter what? 0. So you can leave it like that for the free response. But if you were to go all the way, it's going to give you 3 and 1/3 as our final answer. Is that somewhat approximated? Yep. But then, of course, with our human eye, it's hard to figure out the exact value. All right. So now let's look at number 5. On number 5, we want to graph this. How should I want to graph this? Okay. Okay, for those of you guys that are visual learners, this is just for you. So the total area enclosed by the following. Now I'm going to go ahead and give you your critical points, but before I do, let's go ahead and make our tick marks evenly distributed. More the better. If it's not perfect, that's okay. The first point is going to be at some number. I'm going to go ahead and say it's a dot over here. There's a dot over here, and I'm just approximating my graph. My graph is going to do something like this. And what the problem is wanting is the following. It's wanting us to go ahead and graph this from the x-axis. Oh, x-axis right here. Total area enclosed by it. So it wants all of that on the bottom, and some number over here. And it wanted from 0 to 5, so we should go and write that out. 0, that's 2, 4, and then we're going to stop at 5. So I should have stopped right here. So here's what I want you to do. This part, I'm not going to show the whole thing. So we need to find out the integration from 0 to 2 first, 2 to 4, and 4 to 5 independently, because they all have different shaded region. So let's do the integration of 0 to 2. And I'm going to be lazy and not write the function and write f of x dx. And then we want to find the integration from 2 to 4, f of x dx. In my third piece, 4 to 5, f of x. So here's what I want. I want y'all 5 that's closest to me, find this one right here. That's my group A. And then from Allie to Hudson and Sam, I want you to find the area of this one. And then people closer to the wall from Milo and on, find the area of the last one. Go. You're not finding all of them, just one part that I've assigned to you. You got 30 seconds. Go. Oh, goodness. Ruby, I'll give you 32 seconds. Okay. And check with the group around you. And all of your answers should be something over 3. Something over 3. Oh no, I'm trying to prove what the calculator means. You can leave it as an over 3. You don't need to compute all the way. Leave it as over 3. Oh, 64 might be a little off. All right, my first group A, you got how many over 20? Or I just said it. Did I say it? 20 over 3, right? That's sad. Why would it say how many over 20? I just gave it to you, but that's okay. All right, my second group, that's including Hudson and everybody. How many over 3?
1 second.
1.
Can you do
4 over 3. My last group, how many over 3? Something over 3. You got to integrate and plug in the 4 to 5. Also 4 over 3. So let's see what's happening. This shaded region is 20 over 3. Down here is 4 over 3. To the right is 4 over 3. So here's what the calculator is actually doing. If you are finding the integration, the answer it's going to give you is going to be, or down here that I'm going to look at. Area of this right here on the bottom, I know it's 4/3, but integration says it is negative 4/3. What can we conclude about everything below the x-axis? It is negative. So if I were to go ahead and rewrite this, I have 20 over 3 is above the x, 4/3 is below the x, second 4/3 is above. So that means our final answer is how many? 20 over 3. So here's our idea. Back in geometry, your total area was always positive, whether it was top or on the bottom. The total area is 28 over 3. But the integration is going to include everything above is positive, everything below is negative. Together, it's going to give you the integration. All right? Just kind of keep that in mind. Above and below does matter. So let's complete the equation on the bottom. We're finding the area above the x-axis minus the area of what axis? Below. All right, so with that concept, let's go on to the back page. Because something's going to happen with this one right here. So we're going to wait for that one until the very end-ish. So it says the area of the three shaded parts are given respectively. That means this is 10. That right there, that tiny little part is 1. If you can fit the 1, go for it. And that is our 5. Everyone write that down? Okay? So my first part says from 0 or negative 3 to 0. So here's negative 3. Here's our 0. As long as your numbers are numerically written, the rule still stays the same as what we talked about previously. So would you agree negative 3 is less than 0? So everything above is still positive, below is negative. So in this case, the area above, the first one is 10. I have to include my second one. Do I write it as plus 1 or minus 1? Minus 1. So my integration of that has to be 9. Again, integration is not the total area. It's going to take away the bottom part that's below the x-axis. So let's skip part B and move on to C. On C, is negative 3 really less than 2? Yes? Yeah. So I'm going to go from negative 3 all the way to the 2 in that order. So the first area I get to is what number? 10. My second area that I get to is plus or minus 1? Minus 1. How about my next one? Minus 5. And that integration is going to give us 4. So it's all about below or above and so on. So let's try part D and E with a neighbor. Okay, Milo, how many is our part D?
I don't understand this part.
Okay, so if I start, listen, okay? Negative 1 to 2, that is below, so we write negative 1. And then at 2, from 0 to 2, it's below again, minus 5. So Milo, what would that give us? Negative, boom. So it's all about top or the bottom, okay? And then part E, that's kind of weird. If I start at 2 and I don't go anywhere and stop at 2, and there's no gap. If there's no gap, do I have any area? No. 0. So we like that one. So now let's go to part B. On part B, it says 0 to negative 3. Are we going backwards or forward? We're going backwards. Now think in mind. Think real quick. Negative becomes positive. Positive becomes negative. So here I go. I'll change my pen right here. We are going from 0 to negative 3, and that's numerically not in order. So if I start at 0 to negative 3, below now it's positive. So instead of negative 1, it's 1, because we're going backwards. And the 10 now becomes negative, so we get negative 9. So when you're doing these, make sure you're analyzing the start to the end. If it's numerically done, the rule stays. If it's not numerically done, flip them over. Okay?